Welcome to Lesson 4, ladies and gentlemen. Today we're talking about heat and heat transfer. Your objectives for this lesson are to define and explain heat and to explain the 3 ways that heat can be transferred from one object to another. This lesson will help you explain how energy is transferred from one place to another through convection, conduction, or radiation. Questions for your notebook today, make sure you get these down. What is heat? How is heat transferred from one object to another? So, we talked about this briefly before back in Lesson 1. Thermal energy is the kinetic and potential energy of the particles in an object. It's closely related to heat. Heat is the total amount of thermal energy an object has due to the movement of its molecules. So the molecular vibrations and movements, kinetic and potential energy associated with those is thermal energy. And the total amount of thermal energy in a whole object is its heat. Heat transfer is the transfer of thermal energy from one object to another. On a related note, temperature is a measurement of how fast an object's molecules are moving. There are certain rules for how this thermal energy can be transferred. Heating can only happen in one direction. Thermal energy always transfers from the object with higher temperature to the object with lower temperature. In casual terms, that means a warm object will transfer heat to a cool object. A cool object can't make a warm object any warmer than it is. So if there's a nice cold spoon and you pick it up with your hand, heat will flow from your hand into the spoon, making the spoon warmer. There is some heat in the spoon, but that heat can't get into your hand to make your hand even warmer. So the heat is transferred from the hot object to the cool object. Okay, so then what is cold? Well, cold is not its own property. It's not a separate thing, a separate characteristic from heat. Coldness is just a low temperature or a small amount of heat. Technically, when you eat an ice pop, it's not making your mouth cold. That's how it feels. Technically, coldness isn't a property that the ice pop can spread to your mouth. What's really happening is that your mouth is transferring heat to the ice pop, which lowers the temperature of your mouth. There are 3 ways for heat to transfer. You can see all of them represented in this diagram if you look closely. In conduction, heat is transferred from one particle of matter to another particle without movement of the matter. So conduction is how heat travels along objects. The matter does not move, but the heat is transferred from one particle to the next, atom to atom, or molecule to molecule, down an object or down its surface. Convection is when heat is transferred by the movement of currents within a fluid. Fluid could be a liquid or a gas. Okay, so this could be air currents, currents within water, anything like that. And what happens is warmer spots within the fluid will move in an upward fashion, start to cool due to exposure to cooler areas, and then start to fall. If you've ever watched a lava lamp work, you're seeing it trace out a convection hat. The little blob warms up in the lamp on the bottom. When it's warm, it starts to rise. It transfers heat into the water around it, it starts to cool, sinking. Then it reaches that hot spot over the light bulb again, warms again, and continues. So this is happening in liquids and gases all the time. The hot areas start to move in a certain pattern, transferring the heat around until the whole thing is a similar temperature. Finally, radiation is the transfer of energy by electromagnetic waves. You can feel the radiation from a fire in a fireplace all the way across the room. So radiation is represented by these wavy lines emanating out of the fire in the picture. Now, radiation is the only one that doesn't require matter. Light and other electromagnetic radiation can travel through a vacuum. So we feel the sun's heat due to radiation. Okay, do you think you know these three? Let's try looking at examples and seeing which one is which. Which kind of transfer is this? This diagram shows how heat moves in a current through the Earth's mantle, which is a thick fluid between the crust and the core. So, which type of heat transfer involves currents through a fluid? Check your notes. That's right. This one is convection. Okay, which kind of transfer is this? This person is holding a metal rod in a fire. The atoms on the left end of the rod gain heat, and the heat moves from atom to atom until the right end of the rod becomes hot too. So which type of heat transfer moves from particle to particle? I'll give you a few seconds to figure it out. Yep, we're talking about conduction here. And last but certainly not least, some of the heat energy in the fire transforms into electromagnetic waves. These waves travel through the air and heat the person's hand. Which kind of transfer is this? Well, yes, this one is radiation. All right. So, having seen examples of all three types and the definitions, make sure you have definitions and examples of each one. You may even want to draw in a representation of the diagram or screen grab them from this video or the PowerPoint. And if you have that, then you have all the important notes that you need for today.